Hello guys, and welcome to my YouTube video. Today is a very special day. We're going to be focusing on a very tricky concept, which is phase difference. We're going to start off with understanding what does it mean to say that things are in phase. Okay, that's where we have to start off. Right. In phase basically means the following. It means that things are experiencing, right? Or in physics, particles are experiencing. When things are in phase, it means that they're experiencing the same displacement at the same time. So, if you have particle A and particle B in this diagram, right, you want to explain what exactly does it mean to say things are in phase. If you look at particle A and particle B, let's substitute this with something that you know. Let's say we have Dave and Joe, right? Two people, Dave and Joe, person A and person B, right? In order to say that Dave and Joe are in phase, what it means is that Dave and Joe need to experience the same displacement at the same time. So it means that if it's 2 seconds, right? If it's 2 seconds, since you know that in a wave like this, particles only move up and down, right? So particles only move up, or particles will be moving down. Those are the only two directions that you can actually move in, so up and down, right? So in phase means that those particles are about to move up at the same time. If they're going down, they're both going down at the same time. So it means that if Dave and Joe, if Dave goes up, Joe also goes up. If they're going down, they're all going down at the same time. So they're experiencing the same displacement at the same time. So these two bros are in phase. Yay, right? They're happily in phase. But if they're out of phase, let's introduce a third guy. Let's say Peter. Right here we have Peter, very nice, neat guy, right? But isn't in phase with Dave and Joe. So we have Peter that's showing up there. So essentially these three bros are now so those two guys are in phase, but Peter is out of phase with these two guys. So essentially it means that as they will be moving up and down, Peter will be moving maybe up when those guys are moving down. Peter is moving down when those guys are moving up. So what it means is that Peter is out of phase with the other thing. So they are out of phase. They're not experiencing the same displacement at the same time. That is essentially phase means. Right. So if you understand what in phase means, particles are about to experience the same displacement at the same time, you should know how do you locate particles that are in phase. If you have a phase, particles that are in phase are usually a wavelength apart. Right? They are usually a wavelength apart. Right? As you look in this case, from A to B, from this guy to that guy, it's actually a wavelength apart. Right? So when usually particles sometimes in phase, they'll just be a wavelength apart, or essentially they're about to experience the same displacement at the same time. Right? If they're all going to move down, they're all going to move down. If they're all going to move up, they're all going to move up. So we have to now introduce a concept known as phase difference. What is phase difference? How do we calculate it? Well, phase difference basically refers to how much, okay, the amount by which, right? Okay, so phase difference, what does it mean, right? The amount by which one wave leads or lags behind another, right? It's usually expressed in two things. It's usually expressed, right? Expressed in degrees, okay, or it's expressed in radians. This difference means that particles are now different. More so, waves themselves are different. One wave is leading or one wave is lagging behind another. So we want to find out by how much. By how much is wave A lagging behind wave B? And how do you look at this? If you look at this diagram that I have over here, we have two waves. Right? We can essentially say that one wave is leading or one wave is lagging behind one another, right? So in this case, it's very easy to say at this displacement that is at 0, right? You can easily see that this particle A is wave A is leading. Why? Because if you're moving here, it's going to be the first one to reach maximum displacement first. right? And then wave B follows later, right? Later wave B reaches its maximum displacement. It takes a longer time to reach a maximum displacement. Or this one is an up advantage, it's already starting at equilibrium, has to just move up. This one has to first move, reach equilibrium, sort of lagging behind, right? So we want to find out by how much. By how much is wave A ahead of wave B, or by how much is wave B lagging behind wave A? We sort of want to figure out what is going on here, right? So we have two methods to find phase difference, right? We have two methods. Basically, so if you want to find phase difference, you're a curious learner, and you want to find phase difference, embrace curiosity, right? I have a formula for you. Phase difference is essentially going to be 2 pi times the time interval between 2 points in phase. You're confused again. 2 points in phase divided by the time that is going to take, right? T, this is basically the period, right? This is essentially the period, and then this is the time interval between 2 points. And then you can sort of swap if you're fancy. This is expressing it in radians. If you're fancy, you can sort of express this in degrees. So you can put 360 degrees, right, instead of that thing, right? That's method one. Method two is you can be given, right, a distance displacement graph. So it's basically instead of just putting time here, they can probably put over here. So for that one, we're just going to say 2 pi or 360 degrees multiplied by x over lambda, the distance between 2 points in phase divided by lambda, and you get the phase difference. So if you're here, right, we're just going to explain this. You want to identify 2 points that are in phase, adjacent points, mind you, they must be close to each other. Adjacent, this is the golden rule, okay, and they must be in phase, about to experience the same displacement at the same time. So if I'm looking at wave A is going to reach the maximum height, and then it's going to be here. This is point C or something like that, right? If you look at wave B, it's going to rise and going to reach the maximum displacement, and we're going to call this point D. Now if you're a curious learner, you'd see that point C and D are in phase. Why? Because after this, point C and D are both going to move down. They're now Dave and Joe. If you remember our example, they're both going to move down at the same time. So they're adjacent particles that are in phase, right? So I've identified point A and I've identified point B. So I can basically find the time interval between these two things, right? The time interval, and that's going to be T. So if I want to find my phase difference, it's just 2 pi or 360 times, let's say this distance is 2 centimeters, right? Let's be fancy. Let's say this distance is 2 centimeters. The next thing is for you to find the period. The period is basically the time taken for one complete oscillation, like so. This is your period T. So let's say your period is 4, right? 2 over 4 is actually 180. So it means that one wave leads 180 degrees ahead of another. And if you're confused, what are degrees doing here? It's just a way of quantifying how much waves are out or in phase, because basically we can use degrees. These are sinusoidal graphs, guys. If you did mathematics, you'd know that the graph of sine can actually be represented on a graph, right? And where would actually have degrees and where we actually have displacement, -1 and 1, right? So it shouldn't be a surprise that we can sort of introduce degrees. But here we're sort of now using degrees to measure how much one wave is ahead or how much one wave is behind another. So there was distance on this axis. Instead of me saying time, I'm just going to say x, right? My displacement between them. And instead of me saying t, I'm just going to say lambda, which is my wavelength between those two particles. One last example. If you look at this is your little homework, right? Your little homework. If you look at this, how do I identify points in phase? I pick wherever I want to start. For example, if I start here, right, and I move with it, we go up, we go to the maximum point. I have Dave over here, right? And then if you go here, we're starting at this point, right? We go up. What's next? What next is we go down. We have Joe. So we have a highest point over here, another highest point over here. So these 2 points are basically in phase. So if you find the time difference between these 2 points, delta t, divided by the lambda, divided by the time period, right? I'm getting too excited here. Divided by the time period t, we can therefore be able to find the phase difference. You just multiply by 360 degrees. I want you to understand again a very important concept, that we can have what we call a constant phase difference. Have you ever heard of that? A constant phase difference, right? If you're gonna do waves further, we're gonna introduce this again when we give it a special name. But for now, imagine constant phase difference. What does it mean? It means that whatever 2 points that you pick, the phase difference never changes. For example, if I'm fancy, if I'm going down, I reach this point. If I go down on this, I reach this point. These 2 points are in phase. If I go down, I reach this point. If I go down, I reach this point. This point is about to move up. So if you look at this, these have a difference of lambda. Oh, sorry, these have a distance of delta t, right? These have a distance of delta t. Look at this. All of these distances are the same. So it means that for this graph, the phase difference is actually constant, right? It's the same. If you calculate it, it's going to be the same. There can be scenarios where it's not. They can be. I just want you to be aware of that. There can be scenarios where it's not. How come? Well, you're curious students, so I'm going to show you, right? We might have scenarios like this, okay, where you have one wave that's going on like so, okay, like so. But then you have another wave, that's going on like so, like so, like so, right? Such that if you take 2 points, if I take this point and this point, if I go in and I take this point and that point, if I go in and I take that point and that point, this distance keeps on changing, guys. The delta t keeps on changing, or the delta x keeps on changing. In that case, we don't have a constant phase difference, and that will be very, very special when you do a future video. So stay ahead, keep on watching, right? We're gonna reach there pretty much, right? So physics is pretty cool, right?